Okay, let's begin. We've got a lot to cover this evening, so we're going to get straight to it. So we're now on the second last unit, the learning unit for this course. And this is learning unit 8, and we are going to cover hypothesis testing. So we're probably going to split this into 2 sessions, so this week and next week. And so we should complete learning unit 8 by next week. All right. So let's start by explaining hypothesis testing. I'm going to share my screen and just let me know if you can't see it. Okay, so this is a typical kind of question you'll get for hypothesis testing. And I'll talk you through what this is all about and what the problem is and how do we go about solving it. So if you read this question, it says, the manager of a large shopping mall in Eisner believes that visitors spend on average 85 minutes in the mall on any single occasion. Now, to test this belief, the manager commissioned a study which found that from a random sample of 132 visitors to the mall, the average visiting time was 80.5 minutes. Assume the population standard deviation of 25 minutes and that the visiting time is approximately normally distributed. All right. And the question is, conduct a hypothesis test for a single mean at the 5% level of significance. So what's pretty much happening here is we have this manager of a shopping mall, and what he needs to determine is, he believes that the average time for customers that they spend in a mall. So if you go to a mall and for a specific day, say you go to the mall in the morning, on average, you're going to spend 85 minutes and then you're done and you're out of there. And let's say I spend about 82 minutes. Another person spends 83, another person's 86, etc., 87. But if you get the average of all of this, okay, so if you add all of them up and you divide by how many customers actually visited the mall, so if there was, say, 1,000, right? Then he thinks the average is approximately 85 minutes. All right, so that's what he claims. So this is what he claims. So that's your mu. That's the population mean. Now the thing is, he claims this, but we need to test this statistically. And we have to do it statistically because we have data to back it up. It can't just be like, for instance, if you had to go to the mall and count the number of customers for, say, that visit in, say, the afternoon. So you go there on a Saturday and you find maybe, the average that you walk out is 86. Someone else goes to the mall on a Monday and they find the average to be about 80. So we're all going to get different measurements, right? But that doesn't mean that the manager's claim is false, because you expect some sort of noise and variation in the data, especially when you visit it on certain days. So what you do is the best way to actually do it is to get someone to go on a Monday and then count the number of customers, say for 8 to 10 o'clock. The same person does the same thing on a Tuesday, on a Wednesday, Thursday, Friday. So they capture all of this data over pretty much a week, or you can even make it a month to make it more reliable, and they record that data. And so that's what's done here. This statistician spent some time at the mall and they found a random sample of 132 visitors. And from that 132, so from that sample that they took, right, those 132 visitors, they found that the average for this sample was 80.5 minutes, or 80.5. That's what they found. Now, even though this value is different to what the manager claims, it still doesn't conclude that the manager is wrong. Because if you had just did this test over a week, it could be different to someone who does it over a month. It also could be different to someone who does it during December, someone who does it in June, right? As you can expect, December would have an exceptionally high volume of visitors to the mall. So what you do is we don't have the time, and neither do we have the manpower to do it for, let's say, over a year. But what you can do is you can test this statistically. So if you only capture the data for, say, 2 weeks, you can do a statistical test to determine whether it's reliable. And what error you're prepared to deal with is reflected in this level of significance, 5% level of significance. So when you increase this level of significance, then you allow for, a greater margin of error. All right, so let me just go back to the chat and see if there's any questions. Okay, so that's the idea behind hypothesis testing. And I'll show you now how to actually conduct a hypothesis test to answer this question. All right, so let me clear this board. Second. All right, so now we're going to answer this question. We're going to conduct a hypothesis test. So the first thing, we're going to break this up into 5 steps, and that's hypothesis testing. It's 5 steps, and you just do it systematically. All right, so step 1, state your hypothesis and the alternative hypothesis. That's your first step. Okay. Another name for alternative hypothesis is the null hypothesis. It's just another name. So just keep that in mind. Okay, so another name for alternative is null. All right, so let's do step 1. Okay, so step 1, we're going to state H0 and H1. All right. Sorry, people. The null hypothesis is actually H0. It's not the alternative hypothesis. Sorry, let me just remove that. It removed it. Okay. The null hypothesis is actually H0. All right, so your H0, now remember, if you look at this problem that we're trying to solve, we're trying to test whether this manager's claim is true. So the manager claims that the average is 85 minutes. So the manager doesn't say whether they believe it's more than 85 or less than 85. They believe it is exactly 85. So in how we would state that mathematically is mu equals 85. All right, you can put the units if you want. It's up to you. H1 will be the opposite of that. So the opposite of equals to is not equals to. That's mu not equals to 85 minutes. So your H1 will always be the opposite of H0. Now, I like to place the claim next to the respective hypothesis. So what I mean by that is we are saying the manager believes, okay, that the average is 85 minutes. So out of these two, between H0 and H1, the manager believes H0, right? If you read the text, the manager believes that the average is 85. So I put a note here to say that this is the manager's claim. And there's a reason why I do this, and it's because when we get to the end of hypothesis testing, when we finish the first step, we need to come back here and just check which is the claim, and then we can make our decision. Now this, when you get a hypothesis test with an equals to sign, right, then just know that it's a two-tailed test. Okay, this is a two-tailed test. So you can get cases, which we'll do later, where you won't have equals to. You could have greater than equals to, or you could have less than equal to. When you have these symbols, then it's a one-tailed test. Okay, when you have that. But in our example, we don't have that, so it's a two-tailed test. Okay. All right, so what we've done here is we've completed step one. Okay, so that's step one. Now we're going to move on to step two. Okay, so step two. All right. I would say from our hypothesis testing, remember we're going to have 5 steps, right? I would say step 2 requires the most amount of work. All right, it's not too much. It requires you having to use the table at the back of your textbook to find probabilities. So from all of the steps, I would say step 2 probably requires the most amount of effort. All right, so just focus on this, and if you have any questions on it, please stop and ask me. Okay, it's very important that you understand this. Now, step 2 is to determine the rejection region. All right. Now, one of the key things in the question is that they tell us that the visiting time is normally distributed. And because it's normally distributed, then we would be using the table at the back of our textbook, which we've done last week and the week before. And I'll just show it to you here. It's this table here. If you look at this table, it says standard normal distribution. Okay, so we're going to be using this table to find the probability. All right, now the key thing to find the rejection region is your level of significance. This is key. All right, and I'm going to show you how to use it to find the rejection region. So I'm going to sketch the curve for the normal distribution. It's like a bell-shaped curve. Done this so many times so far from the last 2 sessions, so you should be very familiar with it. Now this is your Z value on your axis, right? It's centered at 0. And now this level of significance, because it is a two-tailed test, what we're going to do is we're going to split that 5% in half. So we're going to split it into half, 5% divided by 2. So that means you're going to get 2.5%. We're going to split that up because we're going to allocate half of that here to the extreme right of the curve. So that's going to be 2.5%. And then the other half is going to be on the lower tail. That's why it's called a two-tail test. It means you have a right tail and a left tail. And you're going to allocate 2.5% there. All right, so that's how we use our level of significance. When it's a two-tail test, we split it in half. We allocate one half to the extreme right and another half to the bottom left. Now, let's just look. I'm just going to draw your attention to this part here on the right. If I know the area on the right of this curve is 2.5%, right? So let's see if anyone remembers from what we did last week and the week before. What do you think this area here that I'm going to shade in green is? Well, let's use blue. What is this area here that I'm shading in blue? Give it a shot. And this is key to actually finding or completing step 2. If I had to shade that entire region there from 0 just before where it starts at 2.5%, what do you think the size of the blue region is? Anyone? Let's check the chat. No takers? Nice, Taneo. Very good. That's right. All right. So remember, if you remember from what we did last week, the area under the curve, the total area under the curve is 100%, right? But because this graph is symmetric at 0, that means it splits it identically in half. So that means the entire area on this side is 50%, and the entire area here must also be 50%. All right. So if you've already used up 2.5% on this part here on the extreme right, that means you are left with 50% minus 2.5%, which is equal to 47.5%. Very good. Okay, all right. Please, it's very important that you understand this, okay? So if you have any questions on it, please let me know now. Now, if you know this blue area is 47.5%, then that means now you can actually work backwards and work out what the value is on the z-axis is. Before, in the last two lessons, we would know this value that I'm drawing an arrow here with. We would know the value on the horizontal axis, and we would use our table to find the area. This time, we got the area, and we're going to find the z value. So we're going to work backwards to do that. So how are we going to do that? And let me just, excuse me, show you the table. All right, so look at our table. So now we know the area from 0 to the z value is 47.5%. So that means you need to look inside your table for the area of 47.5%, or in other words, 0.475. So if we look at our table, we're going to start tracking through the values. 0.475, there you go. There it is here. Okay, so you found the area and the z value that corresponds to it. Now you're going to work backwards. So you're going to go to the left and you'll see it's 1.9 and the second decimal is 6. So it's 1.96. 1.96. Okay, does everyone understand that? Everyone understand how you got the 1.96? It's extremely important you do. So don't get any questions. I'm just going to assume that you do. Okay, please let me know otherwise. All right, so far so good. Now, this is 1.96 on the right. Now remember that property of symmetry, okay? Everything on the right of 0 is identical to everything on the left. It's just that the values on the left will be negative. So if this area is 2.5, and if this area is 2.5, then it means this value here, it's the equivalent of 1.96, but it's the negative value. Now what you've done is you found your critical regions. In other words, you found the region where you would reject H0. So in other words, everything everything from 1.96 to the end, where you have this black shaded region, you're going to reject H0. And everything on the left of minus 1.96, we are also going to reject H0. But for everything in between, we will accept H0. That's how the rejection region works. So everything from here to here in green, we accept H0. All right. So that is step 2. Like I said, it is the most amount of work, but it's very important that you understand it. Now, if you did it in the diagram like how I did it here, it's perfectly fine. It's acceptable and you can't get marked wrong, provided you did it correctly, okay? Otherwise, you can write it out. If you're not going to use this graph and try and do it your own way, you do need to say that you reject H0 if your Z stat is greater than 1.96 or less than minus 1.96. What I just said here that I'm circling is exactly what I'm showing in the diagram. That you reject H0 when it's greater than 1.96 or if it's less than minus 1.96. All right, so you don't have to put the statement here, but if you don't show the diagram that I did on the right, then you have to. That's somewhere in your answer, you need to show where the rejection region is. That's your step 2. Okay, so that's step 2. Now let's move to step 3. All right, so like I said, step 2 is the most amount of work. The other 3 steps are pretty quick. All right, so step 3 is compute or calculate your test statistic. Right, now because we are talking about averages, and when I started this lesson, I told you that the statistician would have collected a sample, all right, 132 to be exact, droppers, and in that sample you'd have an average for that sample, X bar. And here's the value for X bar from that sample in the text, 80.5 minutes. So what we need to do now, if you look at this curve that we've drawn, this is your Z curve. That's your normal distribution. In other words, if you go to your graph that we've been working with, this is your Z curve, right? There's your Z statistic. So we are going to convert X bar into Z. And we have that formula in our formula sheet. We don't need to memorize it. It's in your formula sheet. The formula, and you saw this from last week as well. We did the same formula last week. It's Z equal to X bar minus mu all over sigma over square root n. All right, that's the formula we're going to use. It's in your formula sheet. You don't need to memorize it. All we need to do is plug the values into this equation. Now for X bar, we're going to use 80.5 minutes. This is your X bar. All right. For mu in this equation, well, that's what the manager claims. That's 85. That's your mu, 85. For sigma, right, if you read the text, that's your standard deviation. So it tells you your standard deviation is 25. So sigma is 25. And your n is your sample size, and that is 132. So you have all the values you need to plug into this equation. And if you do that in your calculator, you'll get a value of, tell you now, it's minus 2.07. Minus 2.07. That's step 3. You've calculated the statistic. That's step 3 done. Let me just check the chat. Okay, so far so good. All right, now I said there's 5 steps, so we've done 3 steps. Let's move to the 4th step. 4th step is quite quick as well. Step 4. Step 4 is compare your result in step 3, so your test stat, to your rejection region. All it's telling you is, look at this value that you got in step 3. Now, if you look at our diagram, we're saying everything on the left of minus 1.96, we reject. And everything on the right of positive 1.96, we reject. So if we got a value of minus 2.07, where does it fall on our z-axis? Does it fall in the green area, the green region, or does it fall in the rejection regions? So compare this to your z value on the axis here. So what you're looking for is you're trying to see if minus 2 is between minus 1.96 and positive 1.96, or is it on either side of the 1.96 values? So what do you think? Does it fall in the rejection region or acceptance region? Let's just put that in the chat. Acceptance region or rejection region? What do you think? Give it a shot, please. Doesn't matter if you get it wrong, because this is the opportunity to get it wrong and learn from it. Any takers? How many of you? And the others? No one else wants to try? I'm hoping maybe. Come on, class. Someone else, let's give it a shot. I want 2 more votes. Just want to see. Nobody's fell asleep. No one else? Oh, cool. Good. All right. So minus 2.07 is more negative than minus 1.96. So that means it's here. You don't have to be exact. You just need to know whether it's on the left of minus 1.96 or on the right. And we know it's here, somewhere here. So it is in the rejection region. Very good. So it's the rejection region. So all you need to say in step 4, it is in the rejection region. So all you can just say is reject H naught. Because if it fell in the rejection region, that means you reject H naught. All right, so that's 4 steps. This question does award you a lot of marks. It's at least 8 marks. So you can see there is a lot of working here. That's why it's quite busy. But it's important that you understand all of the steps behind it, okay? So now we know we reject H naught, and that's step 4. The last step is just writing it out in words in a sentence or 2. So I'm going to erase everything. All right. And we're going to do the last step. Okay, so what we found in step 4, we said we reject H naught. Okay, that's what we said. Now I'm just going to rewrite step 1 so you can kind of check what conclusion we make, right? So in step 1, this is what we did. At step 1, we had your H naught, you had your H1. H naught was that your average is 85 minutes, and H1 is that the average is not 85 minutes. And this is why I put that statement, a little comment here, to say that this is the manager's claim. So you've done all of this hard work, right? All the way to step 4. Now, if you're saying you reject H naught, then looking at step 1, right? Reject H naught means you're crossing it out. You know, you don't believe that. If you're rejecting H naught, that means you're not accepting H naught. Do you think that the manager's claim is true or false? Is the manager's claim true or is it false? So you've said reject H naught from step 4. Look at what you wrote in step 1. So is the manager's claim false or true? Okay, I'll let you off the hook on this one. But you got to tell me if you don't understand this. So we're rejecting H naught. So it means I'll put an X here. So that means if we reject that, then it means we have to accept this. So that means the manager's claim is false. That's why I put this comment here. Because in my final step, step 5, I need to say that. How I'll start my statement is I will always mention the level of significance, because that's important, because if you had a different level of significance, it could change the result. So I'll start off by saying at a 5% level of significance, all right, we reject the manager's claim. And find that the average shopping time, because that's what this mu is, it's the average shopping time, Is it shopping time? Sorry, let me just check. Okay, it doesn't say whether it's shopping. It just said that the visitors spend that time. So instead of shopping, let's just say the average time. Let's say the average time a visitor spends in a mall, spends in this mall. Now remember what we said, H0 is not true. So all we need to say is that the average time is not equal to 85 minutes. That's your statement. Okay. And that you are done. You have answered this question completely. 8 to 10 marks there. Right? It's systematic. You got to do step 1, 2, 3, 4, 5, and make sure in step 5 that you conclude it as I've written it here. So you must say your level of significance. You must comment on whether you are accepting or rejecting the claim, and you must conclude in terms of what the problem is. I've seen a lot of students in the past, they just put a statement to say, we reject H0, and that's it. And you may get 1 mark, or you may get 0 marks for that. You have to go into detail like this. So you need to show that you understand hypothesis testing in terms of this specific problem that you're working with, or whatever problem you're faced with in the exam. All right. All good? Okay. All right, so I'm going to move on. And if there's any questions, please let me know. All right. Okay. Let's go to the next page. Okay, problem number 2. Let's read through this problem. Moyes recently launched a new flavored pudding, and the marketing manager now wants to assess the product's success in the market. Now, if average sales per week are less than 5,500, so I'm going to put less than 5,500, the product will be withdrawn. Now, the results from a sample of 18 supermarkets, so this is your sample size, that's your N. It showed that the average sales per week was 5,275, with a sample standard deviation of 788. And the question here is to conduct a hypothesis test to decide whether the product should be withdrawn using a 10% level of significance. Okay, so what do we know? If the sales is less than 5,500, then we should withdraw the product. All right, so just like before, we're going to write step 1, declare your hypothesis. So you're going to have H0 and you're going to have H1. Now, if you look at the question, this time we're testing whether it's less than 5,500. So it's not like before where it was equal to and not equals to. Here, because it's less than 5,500, what you need to remember is that your H0 will always take on either of these 3 symbols. It'll always take on the equals to, or the less than equals to, or the greater than equals to. It never takes the strictly greater than, or the strictly less than, and the strictly greater than. It doesn't take those values. Those values always go to H1. Okay. So if H0 can take on these values, then that means H1 will take on the opposite, which is not equals to, greater than, and less than. All right, so if we look at our problem, we are testing to see if the sales are less than 5,500. So that less than, sorry, not here. Second. that less than, which is here, it belongs to H1. So we are testing whether H1, which is mu, less than 5,500. That goes to H1. Now, if we choose less than to be H1, then the opposite of that is going to be greater than or equal to. So H0 is the opposite, which is mu greater than or equals to 5,500. All right. Now, if you read the text, what we're trying to decide is if the sales are less than 5,500, okay, then we are going to pull the product or withdraw it. So that means if we end up accepting this one, H1, then that means we need to withdraw the product. Okay. Now, if you remember what I told you at the beginning of this lesson, because this time we have an inequality, so we don't have the equals to like before. All right. Now we have the less than and the greater than equal to. So this is a one-tail test. Now you also need to know, is it an upper tail or lower tail? Right. Now this is how I remember it, and it's left to you if you want to follow the same method. All right. What I use to guide my decision, right? When it's a lower tail test, that means that the rejection region is on the left, on the lower end of Z or T. It's either when it's a lower tail or left tail distribution, then this is where your rejection region is. So this is a lower tailed test. If it's an upper tail test, then it's the opposite. Then the rejection region is on the right. If it was an upper tail test, then your rejection region is here. Now, how do we know whether this is an upper tailed or lower tailed test? Now, how I remember it is I look at my sign for H1. So if you look at H1 here, the sign that you have is a less than. I let this be an arrow for me. Like if you had an arrowhead, and that means it's pointing to the left. So that means that the rejection region is on the left. The arrow is pointing this way. So this is how I remember it. It really is left to you. What works for you, but I use the sign for H1 as an arrowhead to point where the region is. So it's pointing to the left. That means it's the lower end. So it's a lower tail test. All right, so that's step one. Okay. Now let's go to step two. But this is the bulk of the work. Okay. Now, this is quite an important say part of this problem, and yeah, just focus on this part. I really need your undivided attention here. So what you need to look at, right, is look at your sample size. Your sample size is 18. So if your sample size is less than 30, if it is less than 30, and in our case it is, right, because our sample size is 18. So check your sample size is less than 30. Secondly, you are working with averages, right? Because if you look at the text, you're looking at the average sales, etc. So you're working with average. Another giveaway is that if you look at your H0 and H1, you're dealing with mu, and mu is an average. Okay. So you're dealing with an average. Your sample size is less than 30. And then look at anywhere in this problem. Does it tell you that the data is normally distributed? Does it say anything about a normal distribution in this text? And if you read the text, it doesn't. So it doesn't say that it's normally distributed. Okay, so I'm going to put normally distributed. And I'm going to put an X there because it's not. There's nowhere in this text that it says that it's normally distributed. Now, when you have all of these criteria met, then that means you're not going to use the Z table like what we did before. You're not going to use that. We're going to use what you call the T table. In other words, the T distribution. So you're going to use the T distribution, and I'll explain that now. This is the table we're going to use. Now, in your textbook, but you'll be given a formula sheet with your tables. Here you got table 1 in your appendix, okay? If you just go to the next page, you'll see the T distribution, all right? This is the T distribution. Now, it's very similar to the table before, to the Z distribution. But there's one key thing you must pay attention to, okay? And it can easily lead you to making mistakes. Now, if you look at the Z table, like what we were doing all this time, the area that's shaded is from 0 to the Z value. So that means this table, it's telling you that everything in this table is the area from 0 to whatever Z value you specify, all right? So, for instance, if the Z value here was 0.11, if this Z value here was 0.11, then that means the area from 0 to 0.11 is here, because there's 0.1 and there's a second decimal 0.01. So 0.11 is here. So it's telling you that the area from 0 to a Z value of 0.11 is 4.38%. However, if you look at the T distribution, that's not the shaded area. The shaded area is on the right of your T value, okay? So that means if you want the area from the T value to everything on the right of it, that's what this table is going to tell you. That's what the, I'm sorry, take it back, sorry. If you look at this alpha points to the area. Okay, the alpha pointing to the area means that when you see alpha in this table, that's the area. So for an area of 0.1, right, for an area of 0.1, there's your alpha. And the value on the axis is your T value, okay? So in other words, let me give you an example, right? Let's say, let's look at this curve here. Let me remove this curve and take you through it. So this is the same curve in your book, centered at 0. Let's say the area here is 0.1 or 10%, right? So the area here is 0.1. Now, I want the T value here on the axis, on this axis here. What does this correspond to? Now, let's go to our table and I'll talk you through it. So what I'm saying here is that the alpha, the size of that area is 0.1. So let's go to our table and look for 0.1. And you'll see it's in the first column, 0.1, right? There's your alpha, 0.1. So which value going down this column corresponds to this value here on the axis? And that's where your sample size comes in. Now, if you look at this column, it says DF, right? Your DF goes 1, 2, 3, etc. The DF is easily calculated by just taking your sample size, DF, it's just n minus 1. That's all it is. In our example, our sample size is 18 because we have 18 outlets. So 18 minus 1. So it's 17. So that means we go down the number of rows until we see 17, which is here. There's 17 there. All right. And remember what we said our alpha is? Our alpha is 0.1. So for degrees of freedom with 17, that T value is 1.333. So in other words, the value here is 1.333. 1 point. Right, that's how you use the table. So the table for the t distribution, your area is given by alpha, and that's the first row of this table, right? And the corresponding t value, once you know what area you're working with, you just need to work with the degrees of freedom to determine which row to stop at. All right. So does everyone understand that? That's how you use the t distribution. We're using the t distribution because Janeo, for both those conditions. Yes, it answers your question. Yeah. If it doesn't say t distribution, then your sample size would have to be more than 30. So to answer your question here, both those criteria must be met. So in other words, your sample size is less than 30 and there was no specification that it was normally distributed. And if these two conditions are met, then you use the t distribution. Okay. Everyone understand how to use the table? I'll give you another example, right? All right. So let's say I'm going to quiz you on this now, right? Let's say your n is 6. Your sample size is 6, right? And you have a curve like this, since it's 0, we're using the t distribution. So here now your area here is, I'll tell you now, it's 2.5%. The area here is 2.5%. If you want to write it in decimals, it's 0.025. Right? Tell me, what is the t value here? Using the table. I'll put the table on the screen and I want you to give it a shot. Okay, so what you're given is you're given your sample size of 6, all right? And you're given your alpha, your size of your area here, which is 2.5% or 0.025. So my question is, what is this question mark? What is the value on the axis using the table? It's very important to understand this, because if you get it wrong in step 2, then you're going to get it wrong for 3 and 4 and 5. Let's do it, okay? Okay, so let's go to the table. All right. So remember what I said, your size of your area is 0.025. So that means your alpha is 0.025. So that's your column. Where do we stop? We need to work out our degrees of freedom. Now remember, our degrees of freedom is n minus 1, which is 6 minus 1, which is 5. So that means your degrees of freedom is 5, your alpha is 0.025, so your value on the axis is 2.571. That's what you should have. And I think you got that, but I'm hoping everyone else understands this, okay? Okay, so that's the value on your axis. All right, so that's just an exercise that I gave you. So let me remove this. Okay, so we've worked it out for our problem. We have degrees of freedom is 17, and we got a value of 1.333. But remember, when we started this session, all right, we showed that it's a lower tail test. So that means the rejection region is on the left, lower tailed. So here is our rejection region, all right? But the reason why we did this curve is because the t distribution, just like the distribution before that we did, the z distribution, it's also symmetric, right? It's exactly the same kind of property. that means everything is symmetric about 0. That means whatever you find on the right is equivalent to what you'll find on the left for its negative counterpart. So the thing is, you've already done the work for its positive counterpart. You've worked out the value of 1.333 when we are working with the equivalent right-hand side of the curve. But we are dealing with the left-hand side, the lower tail test, right? So it's a lower tail test. So the equivalent here will be negative 1.33. So that is everything on the left of this, we're going to reject H0. All right, because that is our critical region. Remember, we don't split this alpha or this critical value. Right? Yeah, we don't split up your alpha because it's a one-tail test. So that means there's only one rejection region. So the entire critical or level of significance value, your alpha, gets allocated to this rejection region. All right. So we reject H0 if it's less than minus 1.333. And everything on the right of it, we accept H0. Okay, so here, everything on the right, we accept H0. All right, so let's move now to step 3. And now the rest of it is kind of similar to how we've been doing it in the problem before. So step 3 is calculate the test stat. Now remember, we are working with a t distribution. So the formula you're going to use from your formula sheet is t equals x bar minus mu all over s over square root n. So the only difference from the formula that we did in the previous question is that before we had sigma and now we have s. That's the only difference. You don't need to memorize this equation. It's in your formula sheet, right? But just know that when you are working with the t distribution, then you need to use the t stat. Pretty simple. If you know you're working with the t distribution, don't go look for a z formula. Look for the t formula. Now you have all the values you need to plug into this equation. For instance, your x bar, it's the average of the sample. And if you read your text, it tells you that there was a sample of 18 supermarkets, so that's your n, which is 18. Of that 18 samples, the average of that sample was this. So this is your x bar. This is your sample mean. This is your x bar, 5275. Your n is 18. Your sample standard deviation, that's your s. Right? Sigma is the population standard deviation. S is the sample standard deviation. So that's 788. And the last thing you need is your mu, and that's, you get that from your H0, but that's your mu. So you have all the values to plug into this equation. And when you do that, you'll get a value of, it is minus 1.211. Minus 1.211. All right, so this is step 3. And step 4 is pretty simple. Compare what you got in step 3 to your rejection and your acceptance region. So based on what you found in step 3, does it fall in the rejection region or acceptance region? So look at your area. So does it fall on the left of minus 1.3 or on the right of minus 1.3? So is it in the acceptance region or the rejection region? That's the question. Okay, I'll do it, but let me know if it doesn't make sense to you. So minus 1.2 is less negative than minus 1.3. It's still on the left of 0. It's still a negative value, but it's here. It's not more negative than minus 1.3. So it's here. So that means it falls in the acceptance region. So that means we accept H naught, or you do not reject H naught, same thing. All right. Now that we know that from step 4, if we are accepting H naught, that it means we accept this, and we refuse to accept this, the alternative. So that means if we are accepting H naught, remember, we were only going to withdraw the product if it was less than 5,500. But we found that H naught is true. So that means it's more than 5,500. It's at least 5,500 or more. So then we would not withdraw the product based on these findings. Okay, so make sure you understand that. And so we would write that out in words. Let me just clear this board out. Okay, so remember, we always start off with our level of significance based on a 10% level of significance. Right? We do not reject H naught. And because of that, we should not withdraw the product. Withdraw the product. So you've mentioned your level of significance. You mentioned whether you accepted or rejected H naught, and you made a comment about the problem that you're dealing with. And in this case, we are talking about whether to accept and whether to keep a product or to pull it or withdraw it. All right. Okay, everyone. That's what I wanted to cover this evening. The floor is yours if you have any questions. Was anything unclear? Anything you want me to go back on and explain again? So to summarize, for hypothesis testing, there are 5 steps. Okay. Step 1, let me just go to my board and give you a recap. Step 1, declare your hypothesis. So you'll state your H naught and H1. All right. Step 2, find the rejection region. Right. Find the rejection region based on whether it's a Z or T distribution. Whether it's a Z or T distribution. Okay, so remember I showed you how to determine whether it's a T distribution. If they don't say normal distribution and your sample size is under 30, then use the T distribution. All right, that's how you know when to use the T distribution. Otherwise, use the normal distribution. In other words, the Z table. Step 3, calculate your test stat. The test stat. Step 4, which is the shortest step probably, is just compare the result from step 3 to your rejection region, to your step 2. And lastly, step 5 is conclude with a statement. Please repeat the part where you said H0 cannot be. Okay. All right. So H0, H0, just remember this, H0 can only take these three values. It can take the equals to, it can take the less than equals to, or the greater than equal to. So it's always with the equals to. Just think of it that way. H0 will always take one of these three, right? The less than equal to, the greater than equal to, or the equals to. So it's always the inclusive value. H1 will always take the opposite of that. So whatever H0 is, H1 will be the opposite. So the opposite of equals to is not equals to. The opposite of the opposite of less than equals to is greater than. And lastly, the opposite of greater than equal to is less than. So those are the three values H1 takes. So depending, if H0 has this, so first figure out what H0 is. First figure out what H0 is, then H1 will be the opposite. Does that make sense? Does that answer your question? Cool. Oh. Anyone else? All good? Okay, please practice on hypothesis testing. It does carry a lot of marks. You know, it's an area where you can easily score marks if you just follow the procedures. All right, but the more you work with it, the better you'll obviously get working with the hypothesis testing. So we'll give you some revision exercises to practice, as I've done before. But please do work through those problems, okay? You can only get good at this if you actually practice it and figure out what you're not understanding. And the only way you'll know that is when you actually work through problems. Okay. That's it for me this evening. Thanks for joining, everyone. But even if you do have questions, if it comes to you later, if you watch this recording, drop me an email. Okay, happy to help. All right, have a good evening, everyone.